Hello everybody and welcome back to Classic Arcade Repairs. My name is Sean and today I have here a Centipede PCB. Well, you talk about classics, right here is a true classic, Centipede. I just put it on the board. I haven't really even looked at this thing. I think what I'm going to do is I'm going to give this thing a good look over underneath my magnifying. Just check it out, make sure it's all looking good. And I've kind of gotten away from doing that, and I need to get back into that habit of looking over these boards really good. Just a good scan. You know, it's good practice. So I'm going to do that first and foremost. Before hooking anything up, I'm going to give it a really good once over the whole entire board, front and back. Okie dokie. Just kind of give this thing a good looking at. One RAM, 2 RAMs replaced. It'd be interesting to see the back of that. Centipede. $74.07. It's been so long since I've worked on a Centipede board. I don't really remember what kind of chips they have. That's a prom. 6560? 6560, what is that? Is that a RAM? This thing has two 7407s. 6560 monolithic memories. 6560. That's got to be a RAM, I would think. It's probably like a 27S00 or whatever RAMs those are. I've just never seen that number. It kind of threw me for a loop a little bit. $555 timer. It's pretty clean up top. There's nothing going on. No badness. So let's flip her over. It's looking good. I really want to look at these RAM, and it doesn't look terrible, but I don't know. It doesn't really look super clean either. No, I don't like that. I don't like the way that looks. I'm going to have to remove those RAM sockets and check that out top side. Check out underneath that socket, because I just don't like the way that looks. It doesn't look clean. It's kind of sloppy. I'll give you a good close-up look of that, of what I'm looking at. And I just don't like the way it looks. I don't have faith in it, so to speak. This chip looks like it was replaced. What is that? No, there's nothing replaced here. Just looks like it's maybe been reflowed solder or something. That's weird. Okay, yeah. No, it all looks good. I don't see any breaks, no damage. It's just those two RAMs that were replaced. Those two RAMs that were replaced, I just don't like the way it looks. And let me grab the camera and show you exactly what I'm talking about. Okay. And I'm gonna kind of zoom in. Give it an angle here. Come on, focus. I hope you can see that better than I can. It just doesn't look good. It looks like it could be hack work. You know, and then this one over here also just doesn't look good to me. So I am going to just remove those sockets. Look at the top side traces on the board and make sure that everything is looking good. Because if it's not, I want to know. I need to know from the get-go that that is good. That work is okay. So yeah. All right. That's the first thing I'm going to do, is address that stuff. So let's do that. Okay, I got the two RAM chips removed. Yeah. I give this guy at least 5 minutes to warm up so that it actually works good without clogging. Coke bottle time. Oh yeah. Oh, goodness gracious. That's a heavy flux solder that was used. pretty overwhelming. So let's leave that guy right here. How about that? Alright, move this guy up out of the way over there. Okay, I don't think there's any broken traces. So things were actually removed good and everything. It's just kind of was solder sloppy a little bit. Heat this guy up because I use my soldering iron to clean up these areas. Just make sure it's really super clean, and you just go around and collect flakies. Yeah, so. I don't like that at all. It wasn't exactly cleanly done, but it's not bad either. Come on, camera. Okay. Nothing is actually broke. And that right there is what I'm not crazy about. It's not a short, but it's, you can see there's just a little damage around. Nothing's broken, nothing's short. Yeah. And no, that is not short right there, that second pin. Okay, so I'll go ahead and solder the sockets back in and put the rams in it, and we'll hook it up, see what it does. I put these two guys in. Basically checking for shorts. Okay. And same thing here. If it's going to be shorted to a trace underneath, it's going to this side, so you can put your probe here and then go on this side, and if it beeps, you know it's a short. I know that none of the traces were broken, so I know that I'm not going to have a open trace. I don't want no shorts. There's no shorting, so it's good to go. I don't want to be chasing my tail over socket issues, so that's good to go. Now I'm going to grab my harness and plug this thing in, see what it does. This will come in. Where is Centipede? Where are you? Centipede, I found you. And the big tote of adapters. Okay. Back up. Let's back up. Okay. Let's plug this baby in. This was one of the first harnesses that I made. Harnesses. Huh. Yeah, let's just do this. Let's just put it like that. How's that? Okay. Alrighty. We are hooked up. Let's plug the AR supply in. Monitor in. So now we have our AR plugged in. We have our monitor plugged in. Parts to parts. And that is right. So let's go ahead. Let's go ahead and monitor our LED. And I want to get out of test and see what it's actually doing on screen. Holy Toledo. I got this thing. Do I have it hooked up right? No, I don't. See, I had black and white. I had my black and white monitor for breakout plugged in, so I need to unplug the black and white and plug in the color. So let me set this guy down. Unplug you. Plug this in over here, see? And then sync. And just kind of plug this in over here. And we have a picture with goofiness. I don't see anything wrong with this. We can just send this back, and this can be a kamikaze centipede. All right. Huh. Definitely got some goofiness going on here. Initial thoughts. What are my initial thoughts on this guy? Pokey is good because that places mushrooms, so I'm guessing the pokey is good. We got bullets going off on the left side of the screen, and the archer is over on the right. That is, moving objects are absolutely goofed up. Centipede is a moving object, and it's just falling. It could absolutely be RAM. You know what? Let's put it back into test because it was telling us something, remember? So let's do that. Test. One, two, three, four, five, 6 beeps. I'm going to reset. Okay, it gave me 6 beeps, so I think I need to look at the manual and see what 6 beeps means. So let me do that, and I'll be back. Okay, I looked in the manual, and it said that 6 beeps is L5, which is... uh-oh. Oh, no, it's that guy. Huh. 94th. Okay, that 9101. That's okay. 93422 is not the same as a 2101. So, excuse me. Excuse me, guys. Sorry. Yep, that is not the same thing as a 2101 RAM. This is a 93-422. So let's come over, and I want to show you guys. I did a little organizing over here. Hi, Lazy. Hi, Lazy. I know it's tough. This is my memory container shelf thing. Memory and CPUs. Yeah. All my memory stuff. Then I got my sockets. These are all sockets. And then down here I have my axial capacitors. And I have up here my radial capacitors. And over here I have all of my TTL. Let's come over here. I can't. Let's take a walk, take a little stroll over here. This is my TTL. And back up. Yay. And I got CMOS up here too. And some miscellaneous odds and ends. Some transistors, analog stuff. Voltage regulators. Yeah, it's my stock. So what were we getting? Oh yeah, 2101 RAM. She gonna yell at you. 2101 RAM. Boo boo. Boo boo. Mrs. Do? Mrs. Do? She's like, leave me alone. I want nothing to do with you. Alright. Oh, be quiet. Alrighty. Let's put you back up here. Little tour of the shop. Kind of cool. So let's place this RAM in here, since it's the right type of RAM, and start it up and see what test tells us. Oh boy, it's still telling us 6. Maybe this 93422, I'm pretty sure this is not the same thing as a 2101. Here's 2101, that's good. It's still saying that it's bad. I'm going to restart. That tells me, guys, that we have a decoding problem. We have probably a RAM decoding, a RAM circuitry problem. So, cool. We get to find an actual logic fault. So I'm going to go to the schematic. I'm going to get the memory access part of the schematic out. And see what's going on. I would say that probably what's going on, I bet you the CPU can access the RAM, but I bet you that the hardware can't. That's kind of my guess. I could be wrong on that, of course, but that's what I would guess, because I would say if the CPU could not access this, it would watchdog. But it's not watchdogging. So I would say that the CPU is able to read and write to that RAM, but when the hardware takes over to read out the RAM, the information that the CPU has dumped into it, I think that's where the hang up is. So I'm going to look at hardware side access to this guy. That's where I'm going to start. That's where I'm going to start, is hardware access to the RAM. So to the schematic we go. You know what I kind of want to do, guys, before Before I jump into the schematic, I want to test my theory about the CPU having access to the RAM. I want to put the Fluke on this thing and run just run RAM and ROM checks. Let's do that first and foremost before we even break out the schematic, because if I can't access the RAM with the CPU, then well, that would be the same issue. It'd just be decoding. But I would be absolutely surprised if I can't get to the RAMs, because the CPU, the thing would watchdog. If the CPU can't talk to that RAM, I would think it would watchdog. So never know. You never know, because the muxes and the decoding for accessing the hardware, for the hardware and the CPU accessing that memory, would go through the same muxes. But those muxes, it might be a signal that's only letting the CPU get to the RAM. But I just want to check, make sure, put the Fluke on this thing, see if I can access that RAM with the CPU. I'm just curious before I break into the schematic and all that. So let's do that. And I think, yeah, let's just do that. Okay, doing some Fluke stuff. I checked the memory map. The memory map for RAM is, and this is typical of almost all Atari boards, the CPU's program RAM that it uses is 0 to 3FF. And that's two 2114s, and they're right here on the board. They're right next to the CPU, basically. So we'll go RAM short, 0 to 3FF. And this, if this was bad, if this couldn't be accessed, there's no way this would even try to boot. So I know this is good. Okay. Good. So now let's move on and do a RAM short. And I checked the memory map, and RAM for the play field and all that starts at 400. And it goes up to 7FF. So we'll go RAM short at 400 to 7FF. And address 410 gives me every bit bad. .411 is every bit bad. 412 every bit bad. Okay, let's do RAM at 400 to 405. Okay. Loop, and that's good. Those few addresses are good. Once you get to, and now it's telling me RAM bits 2 and 7 are tied. Interesting. Now it's okay, okay, okay. These bits are not tied. Bits 0 and 7 are tied. RAM bit 1 is tied. Yeah, we just cannot access these RAMs. That's all there is to it. And so this thing will try to boot. The CPU not being able to access those RAM, it will still try to boot. But it's given me erroneous 6 beeps trying to tell me that a certain RAM is bad, and it's going to do that. If it can't access RAM, it's just going to give you randomness back. So we have a decoding problem is what we have. It's not a RAM problem, so to speak. Right now, we don't know if we have a RAM problem. We have to fix the decoding problem before we can look at the RAM. So that's kind of where we're at. It's kind of what we're looking at. I'm going to go ahead, I printed off the ROM information. I'm going to go ahead and check out the 4 program ROM. So we'll do ROM 2000 to 27FF. BFA 2. And just never mind that phone ringing. Okay, that's good. Next one's going to be 28 at 2 FFF 14 EB 14 EB. Ah, 14 EB is good to go. ROM at 3000. And 600D. It's almost like good. Looks like good. GOOD. And that is 3000 to 37FF. 600D. How come? What's up with that? Let's do a repeat. And it's telling me B14D, B14D. And now it says okay. Let's do a repeat. Yeah, more. 26DD. I'm going to tell you something right now. I'm going to grab the camera. Oops, no, I'm sorry. Okay. Check this out. Good, good, bad. Let's check this guy. That one is going to be 38 ROM 38003FFF. Signature A93C A93C. This one will be good, I guarantee it. Well, I ain't going to guarantee, but you know what I mean. This one will be good. Okay, good. These chips suck. These, if you ever see these things are terrible. Gold-legged Oki. OKI. These chips are terrible. Whenever I see these, I usually just pitch these things. They are terrible. I've had so many of these gold-legged Oki chips. You can't program them. If you try to save them, that's a garbage type of chip right there. That's got to be replaced. So I'm going to replace that guy. You saw it was flaky. It's 3000. 37FF 600D. You remember it was good once, it's failed 3 times. It's just not good. And it just gives me randomness. Yeah. No good. So I'm going to remove this and I'm going to run that test, and remember, you'll see what it's like, EC97 or something like that. Let's run this test. It's like EC97 if you don't have a socket in it. This thing calculates all FF. I think it's like EC97. No, 93.6D. I was way off. Okay. Well, okay, we got some goofiness going on now. Unless... Wow, I might be... It doesn't matter if I went on a tirade about this chip. These things suck anyway. But it might be this one. This might be the first address space. So it might be this one. Nope. Okay, this is definitely weirdness going on. It looks like we have access to ROM problems too. Because that should kick back the same thing over and over. Interesting development. And that one says it's okay. And okay. A93C. I'm going to take this guy let's take that guy and put him right here. And I don't know which, I think that was 2000. So let's do 2000, 28, 3000. Let's do yep. Okay, good. This guy is, okay, 2. Now I've put this Oki chip in there. I put this Oki, this guy, I put in the 2000 range. So let's go ROM 2000, 27FF, and that was 600D. Okay, good. Bad. Okay. .2000 range. That one I believe is the second one, 14EB. Okay, good. Good. Okay. Good. Good. Okay, this was the one that goes here. This one goes here. This guy has not been removed at all. And was this one, did that one give me a bad? Come on. A. Oh, it's A93C. Hey, it was A93C. Okay. Okay, ROMs are good. I need to burn a new, I need to burn this guy. So let's do, RAM was this is program. And our video RAM's still going to be bad. But that was definitely, oops. Yeah, see, that's still bad. But that'll fix, I mean, that was bad. That ROM was no good. So what we will do is, I'm going to put the Fluke up for now. I'm going to burn this ROM. And I'm going to print off the schematic for the RAM schematic. And the decoding and multiplexing and all of that for that RAM. So let's do it. I think that'll be part 2 of this video. I think I'm going to go ahead and give you guys something to watch, because this could, you know, could take me a few days, so I'll put some material up.